Hello everyone, I'm Nieves Montes and I will be presenting the paper Value Alignment Equilibrium in Multi-Agent Systems. This paper includes some work that I have recently conducted under the supervision of Professor Carla Sierra at the Artificial Intelligence Research Institute in Barcelona. So, the motivation for this paper is the value alignment problem, which states that autonomous intelligent systems should behave in a way that is consistent with our human values. In order to achieve this, we need to provide these systems with the tools that they need to consider our human values during their operation. In this paper, we intend to do just that by taking a previously presented value alignment framework and expanding it with some new solution concepts. So the starting point for this paper is this value alignment framework that I just mentioned. It takes a consequentialist view of values, which means that values serve to assess how desirable are the states in the system. And in particular, through values, we can decide which of two states is better. These comparisons come in form of value-based preference functions, which indicate how much does agent alpha prefer the post-transition state S prime over the pre-transition state S with respect to the value V. And then, by accumulating these preferences over a set of sample paths, which are just sequences of consecutive transitions, we can numerically compute the alignment of agent alpha with respect to a value of choice V. In this paper, we apply this framework to a very simple use case, which is the iterated prisoner's dilemma game. This is one of the most established two-agent models in which two players at every transition take one of two actions, either cooperate or defect, and then the rewards that they get are based upon the joint action that both players have taken. Within this model, we want to introduce the values equality and personal gain. And to do that, we design these two preference functions that we believe capture some of the most important features that are related to these two values. And so these functions take as input the accumulated rewards that the agents receive throughout the whole duration of the game. So, considering that our model is very closely related to classical game theory, we choose to adapt some of the most common solution concepts from that field into our framework. First, we adapt the concept of Nash equilibrium into value equilibrium. And so we define that a strategy profile leads to an alignment equilibrium if no agent can enhance its alignment by unilaterally deviating from such strategy. Then we also adapt the concept of Pareto optimality and we introduce the notion of Pareto optimal alignment. And so we define that a strategy profile leads to a Pareto optimal alignment if for some agent to enhance its own alignment, it needs to hurt that of others. Our intention with these definitions is to extend the classical solution concepts into our framework, and so instead of just focusing on the individual rewards, which is the approach that is taken in classical game theory, we are able to introduce many values into consideration. And so here we have some results we have computed the alignment with respect to the two values that we have focused on, so equality and personal gain, for each of the two players. Instead of performing these computations over the whole strategy space, which is a very vast space and would make computations overwhelming, we have focused on two subsets: random action profiles, where both agents behave randomly, and heterogeneous profiles, where we have one agent behave randomly and the other take a more conscious strategy. I will not go into detail into the analysis of the results, that you can find that in the paper, but I would like to point out that this approach allows us to consider situations where both agents prioritize the same value, as well as situations where agents take into consideration different values. And so, to summarize, we have taken a previously established value alignment framework and provided a game theoretical example based on the iterated prisoner's dilemma game. Within this model, we have introduced the values equality and personal gain as preference functions over the states of the system. And finally, the most important contribution of this paper is the new concepts alignment equilibrium and Pareto optimal alignment, which are adaptations from the analogous concepts in classical game theory. These new definitions allow us to take into consideration different values beyond individual rewards, and also lets us consider cases where agents have different priorities. So thank you for watching.